Start. Hello, all. Let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link to get a 7-day free trial. Okay. Now go to our today's question. Our today heap question is this one. Merge K sorted list. Simple. Given an array of K linked list, each sorted in ascending order, merge them into a single sorted linked list and return the head. Okay, so this is our question, merge K sorted list. So we are given 147, like 1 4 7, then 2 5 3 6 8, 2 5, and then 3 6 8. We have to give the answer. So we have to give the answer like 1 2 3 4 5 6 7 8. So this is our merge list, and this is the head of the merge list. So this is given to us, we have to return this one. Simple. So how could we actually do it? Okay, I will not quote the brute force approach. Okay, and I don't think we need brute force approach to solve this. Okay, but you can make it like, you can take and use these formulas to do a brute force approach. Simple. Simple. We are given K list. Okay, so given all list, then track all list head, or I am just taking this actually, this one, because I think we should not more focus on this brute force approach because it is simply a waste of time. Like, you can do many things, like if you just check our previous video of one where we are taking to merge two sorted lists. Simply we can approach it like, we traverse every list, then we store everything into an array, or a vector like 1 2. So this one, like this one. So first, take everything in a vector in a simple way. Simply sort it, which is nothing but 1 2 3 4 5 6 7 8, and then make a linked list. Okay, simple make a linked list with this. So we can solve, or we can do this also, given k sorted list, repeat until all empty, scan the k heads. Okay, move the minimum output, advance the list. Okay, so this can be our brute force approach, or another approach can we use, we take the first two list and then merge them. Okay, so let's like draw me the approach. Okay, so we are given, or just a minute, yes, oh take the first list 1, 4, 7. Okay, so how many lists we are remaining with now? The k minus 1 lists. Okay, so now run a loop, simple for loop, and use the function merge to list, merge to linked list. Okay, with this, suppose take it as list 1, so list 1 and list of this one. Okay, so our code will be like, I will write the pseudocode here only. So suppose we are given a function, uh, suppose we are given the list. So simple for list in list. Okay, so take for every list in list, first point the head, which is nothing but list of 0, simply for I starting from 1 to list size. Okay, then simply get the head from merge to list, take the head and then list of I, and at the end simply return head. This is also an approach to do solution. Okay, but we will be doing something next. Okay, so this solution can be true if you can, if you code, I think you should code it by yourself. Okay, or this solution also. Let me take it down, this solution. You can use this solution also. Okay, so you have to scan every element and then advance in that list, but we can easily solve it using a min heap. Okay, and even the code is much more simpler than anyone. It is much more simpler. So first we took a min heap. Okay, let's to take a min heap. Yeah, let's take a min heap. And when we take a min heap, the min heap store, in the min heap every node store two things. uh, this will be like integer and node star. This integer is always the value, so node value, and this node is this node. Okay, so we store it's the node's value and the node. Why? Because this node value we needed to store, to process everything in a sorted manner, and we are taking a min heap. In min heap the top element is always smaller. Okay, so when we actually design a min heap and we need to make sure a sorted list, we just take the top element from the top. We just take the top element from the top, and it is always the minimum element of the node. Okay, so I think, let me shrink it down, or just mm, this one. So this is our list. Yeah. Now simple. I think I should do it small. Take a min heap. Okay, we are taking a min heap. So store every head into the min heap. So we have three lists and we have three head. So store everything. How do we store? 1 comma 1. This one is the integer and this one is the node. Then simply 2 comma 2, 3 comma 3. So what is the minimum of this 3 node? This one. Okay. So we will take a dummy node. Simple, we will take a dummy node like -1. So it will be our dummy node always. And now into the dummy next, we will store the top of the heap. And which is top of our heap? This one. So put the one, the node to here. And when we are putting the node, okay, node, so this is our node, suppose I, this is our node I. Now we are removing this node from the heap. When we are removing this node from the heap, we have to make sure we insert our the next element if the next element is possible. Simple. So if the next element is possible, insert that, insert that, and just remove this. Now what is the minimum of this? This 2. Simply add this 2. And what is this 2? This 2. So now add the next. Remove this and add its next value, which is nothing but 5 comma 5. So now which is the minimum? This 3. So add the 3. Add the 3. This one is minimum. Now insert this 6. Remove this 3 and insert the 6. So we are just removing this and inserting this 6. Now let me just bring it down to here. Yeah. Now what is the minimum? The minimum is actually 4 here. Okay, so I am doing it like in this side. So this is a singly linked list. So this 4. Okay, so remove this 4 and add the 4, the node 4, add the node 4 to the linked list. And how do we compare? We compare it with this integer value. Okay, so this is integer and this is node. So just remove this node. And what is after 4? After 4 it is nothing but 7. So add 7 here. Value, this is no. Now what is the minimum? This 5. So simply add this 5. I am doing it like from top to down, then from right to left, but it is a single list. Okay. So after this 5, does any element present here? No, this is all null. So this is all null. So we just remove this element. And what is the minimum of this 2, the tree? 6. So insert the 6. Now what is the 6? After what is after 6? This 8. Okay. So remove this 6, add this 8. So what is the minimum of this max heap, min heap? 7. So add the 7 here. Add the 7 here. And what is after 7? Null. So don't add anything. Just remove it from here. So you just remove it. Now what is the minimum of this min heap? Min heap top. What is the minimum of this min heap or the top of the min heap? This 8. So just put 8 here. And after 8, this is null. Okay. Just remove it. So and when we have to return the head, so this is our dummy. So this is our dummy. So our dummy next is our head. See, everything in a sorted way. So we have to make sure this thing. Okay, this is how it's in a min heap approach. Okay, so this one I need to that why we need min heap. If you don't understand this min heap concept, you have to check previous videos. But the reason why we are taking min heap, put the first node of every sorted list into a min heap. Repeatedly take the smallest node, attach it to the answer, and then put that node's next node into the heap. So this is our whole approach. Like this simple two three line I am just doing this. We just put every node head into our min heap, then simply picking the smallest one, and in a min heap the parent it is always smaller than its child, so the root is the smallest one into a min heap. So we just take that smallest thing every time because we are taking in our head. Maybe I am using this thing because it is very common to use this type of structure, but actually it is inside, it is doing the tree structure. Okay, so this is how our approach is. Now let's write down the code, the optimal code. Okay, so we are given actually given lists. Now take a min heap. Into the min heap push head of all list. So all list should be not way, it should be D. Okay, so take a dummy node simply. So um, null node, let's take it, and take a tail as we take, which is pointing to nothing but dummy this dummy. Now there is a element in min heap. Simply take the min heap top and and append to the answer. Simple, simple. Append to the answer, and after taking and appending to the answer, if the top next exists, if the top next exists, then add that to min heap, and at the end simply return the dummy next. Let's evaluate it and check it. Yeah, so uh, this is our pseudocode. Let's write the code, actually the whole code. Okay, with this help of this pseudocode, let's write the whole code. So does this support any formatting? I think there should be some format, it will be easier. So what we are taking at the start, a min heap, and push all his head to the list. Okay, so what could be the min heap value? Okay, So min heap take two values, one integer and another one the node of the integer. Okay. So we can take it in a pair. Simple pair. Can easily take it into a pair. So first our work is take a min heap. So priority queue, and what is our data type? Pair of int comma, and our node is here list node. So this is our whole data type. And this is how we take it as PQ for simplicity. This is our meaning. Okay. So don't be scared because this pair of int list node int, it is our data type. I just insert it into the vector and integrator parameter. Okay. So for that it is too long. Otherwise it is, if you just put integer it will be much smaller. But here for this case we need a proper proper and the proper node, because we are not copying the node, we just take the existing node and just to relink it actually. So our first step is this one, head all list. Okay, so we have to push all head list, all list head into this min heap. So we are given list. So yeah, let's take it like for we'll do 0 I less than n I plus plus, or can you just simply take a list because it is a vector of list. Let's take it like this, it will be much more easier. Auto list of this too much gap. Now put pq dot add two things. So this list loop, and then simple. So for that, every time we are adding the value of the list and actually the head and the head value of the list into the min. Okay, now simply create a dummy node. Okay, so dummy node of new node, let's take it as -1. Then create another tail to just traverse, to like traverse from start to end. Now simply while the PQ is not empty, until the PQ is not empty, simply do one thing, take the top, take the top element like PQ dot top. Now get the top element. Okay, we just take the top element. Now we have to insert the tail next equal to this top dot second. Why? Okay, why this top dot second? Because this top consists of two things, this and this node. So the value of the node and the node. So we just simply take take this whole thing, into a pair, and we just take the whole pair into this top, and we just need the second, and the second is the node. So this tail next should always point to the second. Okay, after pointing that, simply do a pop operation. Why? Because we are removing that node, because we are already. Now if this top dot second, if this top dot second exists, okay, so not exist, second next. So if this top dot second next, so it simply means the minimum head that we are taking now is have another value in the next, so the if the top second next is actually, if it is present, then simply add it to the PQ. So this top dot second next, so next value. So this top dot second is the node, the current node which we actually inserted to our answer. Then we simply go to the next element or the next node of the current node, and then take that value. Okay, so we get that value, and now we need the node which is this one, and after that tail equal to tail next. Simply return the dummy next. Now let's run it. I use add here. It should be push. Runtime error. Okay. Okay. Yes, I understand. If list, if there is a list, then only it takes. Okay. I am explaining it. Let me just run it once. I think this should run now. Yes, because there may be some cases where the input it like 1, 2, uh, then simply cross because the second is null, then take like 2, 5, 6. Okay, so we are given three lists, but for this the head is h1 is this, for this h2, and this is h3. So this is a null. So we are only inserting element when they are not null. Okay. So here you can also see that if it is null, the output should be null. So we have to insert else check before inserting if the element is or the head is present. Okay. So if it is null, this if statement don't work. So let's run it. Yes, it's working. Zero runtime, 100%. So it is big of n log k time complexity and big of a you guess k, you take k list because we are inserting k list into our heap. So this is our time complexity n log k, and space is big O of k. So for this case, the time complexity would be big O of n log k, and the space complexity would become big O of k. So k is the number of linked list and n is the total length of the linked list. So the updated. So the what is n? n is this linked list length. Okay, and what is k? For this, for here k is 3 because there are total 3 linked list. Okay, so n is the size of the answer actually, and k is the size of the number of linked lists given to us. Okay, so this is our approach to this question, merge k sorted list. Go check out the solution, use the solution, solve it, use this link to get a 7-day free trial on this platform. Solve this, use this platform at dsa.chaicode.com. Thank you very much.